Hello children, this is Miss Bazal. I've been practicing to sound like Mr. Brannigan for 2 weeks now, and I think I've finally got it right now. It's Mr. Brannigan really. Miss Bazal unfortunately cannot do the lesson today, so it's me doing the video. So today you're going to be looking at lines and, well, we're going to be looking at lines and quadrilaterals together. So the important vocabulary today is quadrilaterals. Quad means 4. I always think of a quad bike, and laterals means sides, so quadrilaterals means 4 sides. And then we're going to be looking at different types of lines, which are parallel lines and perpendicular lines. So we're going to be having a look at those first. So we've got a special name that we give to 2 lines that always carry on running equally spaced apart. And no matter how long they go on for, whether it was here to the moon, they would never meet. We give these lines the name parallel. We say they're parallel to each other. And to show parallel lines, we put arrows on them. So you can see the arrows are going in the same direction. This shows that the lines are parallel. And that the other important word today, important piece of vocabulary, is perpendicular. So we give a special name to lines that meet at right angles, and they are called perpendicular lines. So you can see the lines have met here, and they've created a right angle here. Okay, and also here, and here, and here. There are 4 right angles there, so we say the lines are perpendicular. Okay, this is a book, and on the front cover you can see the shape of a rectangle. It forms a rectangle. Now, clicking 2 lines which are parallel, which run alongside each other but are always the same distance apart. So I could click on these 2 sets of lines. They are parallel to each other, no matter how long they go on for. They will always be the same space apart, and also I could say that these 2 sets of lines are parallel. Okay, so a rectangle has 2 sets of parallel lines. And next we are going to look at perpendicular lines. So this is where 2 lines join or meet to create a right angle. I could choose these 2 lines. These are perpendicular. Create a right angle. These 2. These 2. And finally, these 2. Okay, there's the right angle there. Sorry, I skipped ahead a bit there. Here is a shape on a grid of paper. It's a trapezium. Okay, and it's saying click a side which is parallel to CD. So we've got the line CD here. Now I want a line that's parallel. It's not this line that's parallel to it because they aren't touching each other. And remember, parallel lines are the same distance apart, no matter how long they go on for. D to A, DA and CD, they create a perpendicular line. They create a right angle. So it must be BA because they run parallel to each other. Okay. I can click next. Come on. Here we go. This is a trapezium in a different orientation, just a different way around. It says click a side which is perpendicular to AB. So I need to click the side that is perpendicular, that creates a right angle. Well, this clearly doesn't create a right angle here. It's smaller than a right angle. It's acute. DC would be a parallel line. So AD or DA, depending on what you want to call it, would create a right angle here. So they are perpendicular. Okay, we're going to see some clues now. And after each clue, I want you to try and draw what you can imagine in your mind. This was one of the objectives from the start. It's visualizing a 2D shape. So if you want to pause the video now and grab some paper and a pencil, maybe a ruler. Squared paper would be much better if you can. So the opposite sides of this shape are equal. The opposite sides are parallel. So it's either a square or a rectangle, because the opposite sides are both parallel and the opposite sides are equal. Each angle is a right angle. Squares and rectangles both have 4 right angles. All of their angles are right angles, and it's got 4 sides. A square and a rectangle, again, both have 4 sides. One pair of sides is longer than the other. That is the clue that should tell you that it is, of course, a rectangle. And let's have a look. Opposite sides are equal, similar to a rectangle. Opposite sides are parallel, again similar to a rectangle. Each angle is a right angle, exactly the same as a rectangle. It's got 4 sides. All 4 sides are equal. That lets you know that it's a square. They're all of equal length. Okay. All squares are rectangles, but not all rectangles are squares. A quadrilateral is a shape with 4 sides, which is, like I explained earlier on, quad. Think of your quad bike, 4 wheels, and lateral is side, 4 sides. So here are some quadrilaterals. We're going to look at the properties. I'm not going to click on the square and the rectangle. We've already looked at that. I'm going to click on this parallelogram here. So this parallelogram, it's a quadrilateral because it has 4 sides. Its opposite sides are parallel. You can see here that these opposite sides are parallel and they're equal. And these opposite sides are parallel and they're equal. However, not all of the sides are the same length. That is a special type of parallelogram that has all of its sides the same length, and that is a rhombus. Okay, so it's got opposite sides that are parallel. It's got 4 sides that are equal and all the same length. This is why it's a special type of parallelogram. It looks like a square that's fallen over, and actually the parallelogram looks like a rectangle that's just leaning over, doesn't it, about to fall over. This quadrilateral is called a trapezium. So it's got 1 pair of opposite sides which are parallel. You can see there's the 1 set of sides here, and there's the 1 set of sides in this trapezium. Now some trapeziums do have lines which are perpendicular. They create a right angle, and some trapeziums do not. So that is one to look out for during today's lesson. Finally, we'll look at the kite. There's 2 different versions of a kite there. This is the one you're probably more familiar with because it's the one that you often see flying on a windy day. It's got 2 pairs of equal sides. So these 2 are of equal length and these 2 are of equal length. 2 pairs. However, they don't run opposite each other. They run adjacent to each other. Adjacent means next to. This kite here, these 2 lines are adjacent to each other, and these 2 lines are adjacent to each other. So we've explored some properties of equilaterals now. Now we're going to look at a rectangle. We're going to look at some diagonals within the shapes, because these can create right angles, so they can be perpendicular. Let's have a look at this rectangle. Are the diagonals equal in length? So in a rectangle, that's 6 centimeters long. Make sure the 0 is in the correct place. I'm measuring it correctly. And this diagonal, it's 6 centimeters long. You can see that they cut each other in half. Okay. However, they don't create a right angle within. Smaller than a right angle, and these 2 sides are smaller, and these two diagonals here where the angle is, the angle is much larger than 90 degrees. We're going to change the lengths of the sides now so that they're all equal. So it should create a square. There we go. Now, you can see they're all equal. The diagonal lines are going through each other. And we're going to check where they meet. Does it create a right angle? I've just given it away. I should have said, what angle do you think it will create? The rectangle didn't remember. Because the square has sides of all the same length, sorry, let's do that again. It should create a right angle. There we are, there's the right angle there. You can see 90 degrees. The diagonals of a square cross each other at 90 degrees. And there's 4 right angles in there. You should be able to imagine. Okay, here's a parallelogram. Oh, sorry, I've skipped ahead there. Here's a parallelogram. Well, I've already told you the answer. A to C is actually shorter than D to B. They do not measure the same length, similar to a rectangle, because all of the sides are not of equal length. A square and a rhombus, they will create right angles where the diagonals meet up, because they are all of equal length. A square has diagonals of equal length. As you can see. Now the interesting thing here is the rhombus doesn't actually, sorry, the rhombus does actually have diagonals that are the same length, which is, like I've just said previously, like a square, so it creates a right angle too. So the lines are not equal, they're ever so slightly out, but they do create a right angle, because just like a square, the lines are all the same length. Okay, there's another quadrilateral which has diagonals that always cross at 90 degrees. Have a think, and you think of what it might be. It is, of course, the kite. Okay, it's got its diagonals here, where we join the sides up, and you can see quite clearly a right angle. There would be one here, and another here, and another here. Okay, we're going to see some clues now about a mystery shape, and then we're going to click on the shape when we know which one it is. I might run through all of them. So this shape, all of the clues that is, this shape has 2 pairs of parallel sides. Well, this kite doesn't have any pairs of parallel sides, because eventually the lines will meet up. The rectangle has 2 sets of parallel sides. So does the parallelogram. The trapezium only has 1 set of parallel sides, because these 2 would eventually meet up to form a triangular shape. The square has 2 sets of parallel sides, and so does a rhombus. So at the moment it's between rhombus, square, parallelogram, or rectangle. All angles are 90 degrees. Well, it can't be the parallelogram or the rhombus, so it's now between the square and the rectangle. Not all sides are equal. The square has sides that are all equal, so therefore it must be the rectangle. Okay, children, when you have a go on yours, if you click on this lesson, you can look at some more clues and have a guess until you are confident that you know the properties of each one. I would definitely recommend that before you attempt your work today. And now we've got some shapes to investigate. I am not going to click on all of them. We've investigated quite a lot of them. I would strongly suggest that you come on and have a look at them before you attempt the work. I'm just going to show you what the work looks like today. So, similar to what we were just looking at, there are some clues. This shape has one pair of parallel sides only. So one pair of parallel sides. It's got no right angles. Well, that's got no parallel sides. That's got two sets of parallel sides. That's got two sets of parallel sides. Square's got two sets of parallel sides, and so does the parallelogram. Therefore, the trapezium is the only one with one set of parallel sides. Now remember, the trapezium could have a right angle, but this one doesn't in this case. So please get that one right. It'd be slightly embarrassing if I didn't get it wrong now. Okay, it was the trapezium. And now let's have a look at question 2. Just children, notice the way that I looked at each shape and compared them all. I didn't just guess one. I reasoned. I used my reasoning. Well, it can't be those because they've got two. That hasn't got any. So therefore I knew that it was the trapezium. It only had one set of parallel sides. Now we are going to complete the quadrilaterals. So it's going to tell me to make a shape. I've got to put in the coordinates correctly. Remember, along the corridor, up the stairs. So let's see. What are the coordinates of D? So where's D going to go here if I'm going to make a trapezium, not a rectangle? Well, if it was going to be a rectangle, I know that it would have to be here, which would be 2, 8. I'll just show you that. Here we go. Two sets of parallel lines to the same length, not all the same length. But I don't want to make a trapezium. I don't want to make a rectangle. I want to make a trapezium, which again has to have 4 sides. It's quadrilateral. So, I mean, I could create lots of different trapeziums here. I could go for 2, 3. That's a trapezium, or 2, 4, or 2, 5, or 2, 6, or 2, 7. We'll settle for 2, 7. Let's have a look underneath. It says, do the diagonals cross at right angles? No, the diagonals in A. Trapezium do not cross at right angles because the sides are not all the same length. What are the coordinates of D if A, B, C, D is to be a rectangle? Okay, so we need to make a rectangle here. It's more difficult to see the rectangle. I'm going to imagine my line up here. So it's definitely going to be 10. Might need 2 goes at least. It's difficult to see on the screen. It's definitely going to be in 10. I'm going to go for 6 and see what that one looks like. We'll know straight away if it's a rectangle or not. Ah, there we go. I've got it. So there is a rectangle. It's got 2 sets of parallel lines and opposite sides are the same length. Do the diagonals cross? No, they don't, because when the diagonals cross make a right angle, it was a square and a rhombus, wasn't it? Okay, thank goodness for that. I got them all right. Because Al would definitely have told me off if I got them wrong. I hope you've enjoyed it, children. Good luck with the lesson. If you've got any questions, then please ask your teachers on your blog. You can ask me now. I'm a professional. Thank you very much. I hope you have a lovely day.